Thank you. I didn't. That's the first time I've ever been introduced as a diversity speaker. Cool. So nice seeing a lot of familiar faces in the crowd. I'm curious, how many of the people in the crowd are like leaders, managers, or play that role in their organization? Okay, cool. So most of you. This is an interesting chat that I put together because often I have a discussion with my significant other, and she's like, "What do you do?" And I'm like, "Oh, well, she's not in tech, so it's a little difficult to describe." Something that I teach a lot of leaders when they start becoming leaders is trying to understand their role. What is the role of an engineering leader? And the goal is quite simple. Our job is to deliver on time and meet expectations. Like that's it. That's what an engineering leader does. And through that, we create a lot of processes. We do a lot of different things to make that happen. But one thing I've learned over the years of growing teams, organizations, is that when teams grow, they tend to slow. And I know that has a good rhyme to it, but it's not great in practice. So why is that the case? As you know, when you have just 5 developers around a table, it's pretty easy to get something done. You're all sitting there, the coordination tax is not that high, the number of connections is not that high, but as the team grows, the number of connections explodes. And this becomes very difficult to manage. So, the coordination and cooperation tax is real. This is basically reflected in complexity. So we end up with a lot of complexity, we create processes, we start measuring things, whereas in the beginning, we probably wouldn't do any of this stuff. So why is it that we do this, right? Sometimes in Agile, what we do is we start measuring things like velocity. So velocity, something that a lot of teams do is measure how fast or how much work can their team get through. So then they start scoping projects, trying to understand, is this thing a lot of work, a low amount of work, and can our team get through it? What's the burn down going to be like? The problem with velocity is it measures the amount of work, but not the value of the work. So this is very important. Value is what is perceived by the customer, the client, as something that actually is what they're looking for. Remember, our job is to meet expectations, right? So when we talk about product value, product value is if it meets the expectations of the client. It does what it is intended to do. So, in this picture, it's kind of a piece of, clip art stuff, but it's basically, it fits the puzzle. It does what it's supposed to do. Customers care about product value. They don't care about effort, okay? It doesn't really matter how the pyramids are built. You could build them with new technology if you really wanted to. The purpose of it is the value. So what are you getting out of this? So waste is something that increases time, cost, and effort to get the same result. When we're looking at our processes, we want to cut down on waste because by doing so, we can do it cheaper, faster, and meet the expectations sooner. So that's why this is important. That's why we talk about waste. So when I talk about building teams, often I have a lean slant to it. I'm on the lean side of Agile, and what that means is lean is from Toyota. Toyota created this system for developing cars, but in a very different way than at the time U.S. auto manufacturers produced cars. Whereas U.S. auto manufacturers were producing cars based on number of engines produced, how many doors they were able to create. Toyota was very focused on producing a car to completion. And their process is really around reducing waste and getting that vehicle to the client as soon as possible. So, the rest of this talk is really about ways to identify waste, bad smells, and things that you can do in your organization to reduce that waste, to make your organization more efficient. And efficiency is important because we go faster. That's, as an engineering leader, that's probably your biggest concern is how do you get your team to go faster? So like the 7 deadly sins, there are 7 deadly wastes in Agile or in Lean. And I'll kind of talk through each of these, and hopefully we can come up with some frameworks for how we can help our teams reduce their waste. Okay, so the first type of waste that we're going to chat about is partially done work. So this happens on a lot of different teams. It doesn't, like the customer doesn't really care how long it took. Like no one really cares how much effort it took Apple to create the iPhone, right? We don't care. We like using it, but we don't care how much effort it took. And the product is not measured on effort. So, oftentimes we become bean counters, right? Like as leaders, we're like, oh, how much effort did it take? How much time did something take? But partially done work is a huge waste. So if I start doing something and then I tell someone else to do something else, you now have 2 pieces of work in progress. These are both pieces of partially done work. There's no value. It hasn't gotten to the client, so there's no value. So this is a huge form of waste. There's some bad smells. So you have many individuals working on many different features and tasks, right? This is another form of waste that we'll get into. But basically, when people are doing many different things, they have many different things that are work in progress. This is all partially done work. Maybe you also hear that a lot of tasks are blocked. A blocked task is basically a piece of partially done work. So how do you fix this, right? So in Lean software development, we have this idea of Kanban. So Kanban is a one-piece pull type of process where you try to finish what you're doing before starting new pieces of work. So you're not optimizing for velocity, you're optimizing for product out the door. Okay? So the second form of deadly waste is overproduction. You can think of this in terms of manufacturing, right? You make too many cars, who's going to buy these things? No one wants it. In software development, we have something, who's familiar with Y Combinator and the saying, build something people want, right? So when we build technology that no one wants, and we expect like a sales team to sell it, that's waste. Technology doesn't appreciate in value. It sits in a repo, maybe it sits in production, but if it's not used, it's actually wasteful. We spent hours, hundreds of hours potentially, building this thing. And product actually depreciates. It's technology. Technology degrades probably faster in your food, in your fridge, right? So this is a huge form of waste. So what are the bad smells? Unused or extra features. Probably have tons of them in your software. They cause all kinds of problems. Sometimes they cause bugs. Sometimes they're latent bugs. And then when you discover them, you're like, oh, I didn't know that software did that. So these are forms of waste. And often when features take too long to develop, what we're doing is we're creating that waste. We're actually creating features that no one wants. So the question is, how do you get over this? So obviously, focus on MVPs, build more MVPs, get things into the hands of clients, reduce iteration time. So this is important because if you reduce iteration time, what you do is you actually get things into production faster. By doing this, it allows us to discover if this is actually useful. So the last little possible remedy is to favor just-in-time over big design up front. So, why do you need to design all this stuff? Why can you reduce the time that it takes to get to production so that you can get there faster? Okay, so the next form of waste is relearning. As organizations grow, you hire more people, you have to onboard them. It becomes difficult. How do you teach them all the things that you and your team have learned in the past? So learning takes time. Many of us took decades to acquire the knowledge that we have today. And my memories got worse as I aged. And software is complex. So how do we build learning into our software is important. Repeatedly paying that learning tax is very taxing on the team as it grows, because if everyone needs to pay that tax, you end up paying it multiple times. So you get no leverage from that. If anything, you're paying for the leverage by multiplying out the learning. So what are the bad smells? Multiple people investigating similar problems, recurring problems in production. So you have operational problems that you see time and time again. Maybe today, your friend is on call and he's solving this problem, but tomorrow, someone else is on call and solving the same problem. So the learnings are not captured by the system. So these are bad smells. And maybe there's effort duplication. As teams grow, one of the strategies is, maybe we create squad teams, right? So if you create squad teams, there's a possibility that these teams are solving very similar problems. So how do you overcome that, right? Technical knowledge base. So most companies probably have like an internal wiki of some sort, or use some type of system for sharing knowledge. Sharing knowledge is super important, so get the setup, right? The other common pattern that we have in software development is to dry it up, right? So to overcome, teams recreating the wheel all the time, create shared libraries, right? Do it once, communicate it broadly, make sure it's adopted. And the last possible remedy to aid in relearning is to build automation and smarter tools. So smarter tools are interesting because a lot of teams build their own tools. Dev tools are super important for increasing productivity, but smarter tools will actually tell developers how to do it right instead of here's an error, right? Because the error is only a way of telling you that it didn't work. But if the tool is smarter, it will tell you how to fix it, and so you don't have to learn. Okay, so the fourth type of waste that I have are handoffs. So the problem with handoffs is you get a loss of context between people. Move something from one team into another, you have a loss of accountability, a loss of momentum. And this increases the time lag between work. So think of this in terms of in auto manufacturing. If I were to have a team that makes engines, then a team that makes doors, and then I have a QA team, if I have to wait for the engine, then wait for the door to be manufactured before I can actually get to QA, I create artificial lag. And this actually extends the process. The reason why this is really painful is because by the time you actually discover a defect, you might have to go back to the beginning of the process to fix these defects, but that team might be doing something different. So what are the bad smells? So front end versus back end teams. Many teams, myself, I've committed these types of faults in my life, right? You have a front end team that is working on something, and they're like, I need the back end team to work on it. The back end team works on something, and then it's like, I did it, where's the front end team? Oh, they're working on something different now. So this handoff creates an immense amount of lag. And the end result is that the customer sees that the product is late. Or you're like, why is it taking so long? Oh, they're working on something else. So QA teams is another really interesting one. QA teams, this handoff actually creates an accountability problem. So when you have teams that basically move from doing development to handing off development to a QA team, what ends up happening is the QA team only has the ability to identify defects. They do not have the ability to fix the defect. So what do they do? So they say, I flag the defect, I give the defect to an engineering manager. Engineering manager needs to triage the defect to ascertain whether it's worthwhile fixing or not. And then the team ends up having to pull someone off of what they're working on to fix this defect. They have no context. It could have been days, if not weeks, after they had developed this feature, and now they're expected to fix it. So now they've created another form of waste, work in progress waste, right? Partially done work, and they have no context, so they have to ramp up again to fix this problem. And then after they fix the problem, they give it back to the QA team to do this verification of the feature. So as you can see, this type of handoff creates a lot of waste and time loss. And of course, deployment teams. If you have deployment teams that are like trying to deploy your software for you, the person who developed the software cannot be accountable for what it's doing in production. So the question is, how do you make them more accountable? So here are some possible strategies you can employ. Full stack dev teams. This is very common to create teams or squads that have the ability to do everything from building software, testing the software, and getting it deployed. Empower those teams to do all these things. The other thing a lot of teams do, and that I live by, is increase developer involvement in testing. Make them accountable for their software. Get them to test their software. What is the value of someone testing it for them? What are we gaining? Can we create a process that encapsulates that and automates it? Test automation is huge. You get all this time back because the computer is doing it instead of us, and of course CI/CD infrastructure. Okay, so the fifth type of waste is delays. So this is related to handoffs as well. So we create work in progress whenever we create handoffs, and the time starts to extend. Anytime a feature is sitting on a shelf waiting for someone to do something, it's time that's not in production. Right? Time that a bug is still in production, or time that your customer cannot give you that feedback. So it increases the cost of a context switch. What you usually see on teams is we're waiting for resources to become available. You hear this from people. It's like, I'm waiting for so-and-so. I'm waiting for this. So how do you fix this problem? Again, squads or pizza teams, and you rearrange your development process to optimize for something called one-piece flow. So get that feature out the door. Optimize for getting features out the door instead of optimizing for velocity. The sixth form of waste that I have here is task switching. As you know, humans are terrible at this. We think we're good at multitasking, but it's really not true. Every time I have to do a task switch, I completely forget what I was doing. I ramp up on this new task, and then by the time I finish that task, I even forgot what the previous task was. So the cache miss is huge. So with us, we should reduce these types of switches. And you hear this on your teams, right? You can hear them when people are assigned multiple tasks. You ask them, why are you working on 4 different tasks? Which one are you actually working on? They only have 2 hands, right? And they only have 2 hands. They can only work on one thing at a time. So multitasking doesn't really exist. It's an illusion that we're telling ourselves. Another thing that you often hear on your teams is jumping from fire to fire. So you have, there's a fire, someone's yelling at you, so you're like, okay, I'll get someone to deal with it. And then you hear another fire, and you're like, okay, I'll get another person to deal with it. And before you know it, you have all these fires, and everyone on your team is firefighting. This is a form of task switching. They've moved off of something to fight that fire. So how do you remedy some of this? So you can put some good guidelines in place. 1 task per person. Optimize for one-piece flow. Don't take them off the task until they're done. Create an on-call. Create an on-call rotation. Limit the interrupts to a certain person instead of having everyone on your team fight fires. There's something called Tack Time in Lean, and that's really about understanding what a unit of work is. So one of the strategies I have for my teams is usually the rule that the developer deploys what they start that day. So this reduces the tack time to essentially 1 day. That means if you are able to stop a developer at the beginning of a day, they haven't started anything new. What they've done already was already deployed into production. So you can interrupt them. So it's a very, very different strategy than saying, okay, I give you 2 weeks to work on something, and I don't hear from you for 2 weeks. So this is a strategy that, that works well in practice. Or you have a fixed time for tasks. You're like, this is what I call the Bob Ross analogy. You know, Bob Ross has 30 minutes to paint a painting. He never fails. And sometimes he actually does it faster than 30 minutes because every stroke that he puts down is accretive. It adds to that end result. So he could stop at minute 15 and it would be okay. So, you know, understanding the fixed amount of time is incredibly useful for helping someone think about things that they need to deliver on every single day so they can get it out the door. Okay, so the last type of defect is defects. Oh, sorry, the last type of waste is defects. And this is really around developers going back and fixing things. So the problem with this, and I can describe this in terms of auto manufacturing again. So everyone is probably familiar with the problems that Tesla had with manufacturing. So what happened was they were trying to reach a certain number of vehicles produced. And the end result was that the cars were actually very bad quality. They were producing a lot of doors, a lot of engines, a lot of batteries, and they were asking teams to produce it in an assembly line fashion. The car would roll off the assembly line, and then they would discover that they can't put the last panel on because the last panel didn't fit because they manufactured 10,000 bad panels. So then they would have to get the team to shave down the panel to make it fit properly. So this is a defect. And defects discovered late in the process are extremely, extremely expensive for software development teams and manufacturing teams because it requires someone to come off the process to fix it. So, what is the strategy for dealing with these things? So bad smells, are bugs and poor operational excellence. So what do you do? There's a strategy called building in quality while building. So you test while you're building. Don't test at the end. Don't save testing for the end. Write unit tests early. Write integration tests early. Even write end-to-end tests early. Because if you can deliver sooner, you can write those things sooner. And if you are already in a world of operational hell, do some bug bashing, right? You have to clean up the mess. Otherwise, it's just something that piles on and on. Hopefully, these wastes, you've seen them in your organizations, and you can apply some of these things to try to help. It's really important for us to understand as leaders, what is it that we're trying to do? What is it that we're trying to help our teams do? And to get them to move faster is not about additional processes. It's often helping them realize that there's better ways of doing things. So that's it. Thank you.
All right, questions, concerns?
Thank you. Thank you for that talk. Right. I have a two-part question. First part is, obviously you have to be able to measure these things to fix them.
I'm sorry, I couldn't hear that.
Right. I have a two-part question. How do you measure each one of these things or some of these things so you can actually fix them? So you can discover where your actual problems are in the myriad of the list that you described. And then how do you use those measurements to drive kind of positive morale rather than them becoming a measure of performance of the teams that are under the microscope?
I'm sorry, I had a really hard time. I couldn't really hear that question very well.
One, how do you measure?
Can you measure success?
No, how do you measure the problems?
Okay, so the first question is, how do you measure the problems?
And the related question is, how do you make sure that those drive positive behavior instead of becoming lens on things?
Okay, and the second question is, how do you drive positive behavior? Yeah.
Okay, so the first question is around how do you measure some of these problems, right? So, sometimes teams do like retrospectives, or, I think the one thing that I see is when features are not delivered. So, time is the best measurement, right? Like whether something delivers on the time that they expect it to deliver. So the thing that I would use is how much time do you expect this tack to take, like this tack time? If it's a one-day task, right? Like if you say today is one-day task, and the task after one day elapses, you start seeing that there's a problem because time is being pushed out. So at that point, that's when you have to evaluate. It's like, why are you not able to deploy that thing that you worked on? Is there quality problems? Is the infrastructure not supporting these things? And then that's when you try to implement a remedy. And I think the second question was around morale, right? Like how do you make it so that it's not defeating, right? Like I think teams in the past, what they do is they actually spend time to try to celebrate identifying waste. So I think it's super important that teams identify waste and they're like, this is great. We've quashed this type of waste. Look at all the productivity that we're going to get out of it, or look at all the acceleration that this will give our team.
Hey, would you consider quality of requirements one of deadly sins?
So I guess the question is around requirements, right? Like how would you deal with requirements? So the way I would look at requirements is understanding what the goal is. So you can imagine if you left me in a desert and you told me to just get out of the desert. I would probably act very myopically. I would look ahead of me. I'd be like, oh, there's a rock there. I should probably avoid the rock. There's a river. Maybe I go around the river. But I would end up in some place at some point, and it's probably not where I want to be, right? Maybe I wanted to go east and hit that town, and I ended up with a river in front or an ocean in front of me. So I think it's important for teams to understand what the goal is, right? What is the goal? And then every day, what they're doing is to deliver on that goal. So it gets them a little bit closer, but they're delivering working software. So something that can be deployed to production, that can be verified, and works. So the foundation is constantly being built up on something that can be of value to the client.
Hi, what is your take on the Scrum ceremonies, like Scrum, Kanban ceremonies, stand-ups, grooming, Scrum of Scrums, and all these things? Do you consider that as the eighth waste, or it's more like part of the process?
Okay, I think it's important to understand what Agile is and what it tries to help people do, right? So Agile is all about getting software into the hands of customers faster so that you can get feedback. So the more frequently you can deploy software, the more frequently you can get that feedback. So what is the purpose of Scrum or Kanban or any of these processes that, these methodologies that we build up in the world of Agile? And the purpose is to limit the amount of work, right? By limiting the amount of work that we're doing, we increase the frequency in which we will get something to production, right? So then you can break down the process and understand why is it different, right? How are these two things different? So they both try to do the same thing, right? Like they're both trying to get software to production sooner. The difference is that with Scrum, what you're doing is you first isolate all these projects that you think that you can do. Then you start working on them in a sprint fashion, right? And at some point, you're like, okay, the sprint is done. So you cut off everything that's not done, and you end up with a bunch of tasks that were done, right? And a bunch of tasks that aren't done. And then you roll those unfinished things possibly back into your backlog or into another sprint. What you've done is you have delivered software. It's not bad. It's terrible. It's actually terribly good, right? That you've been able to do this. Now, contrast that to what Kanban is trying to do. Kanban is trying to also limit the amount of work in progress. Only people can take cards and work on them, and work them through the process to get them deployed. The only difference is that it's continuous. There's no end in sight, right? Like there's no need to create sprints or anything of the like. The next card that someone picks up after they're finished with that task is the next most important task. So that product owner, or PM, or even engineering manager, whatever you have in your organization that is prioritizing these tasks, they're gonna rearrange what is the possible next task that people can even pull off. So it's a more continuous process. They're both achieving the same goals. Like I don't believe that one is necessarily better than the other. It depends. Really works for your team. I personally like to use Kanban.
Hey, you talked about QA teams being a bad smell. I wonder if you've ever had any experience or have any thoughts about transitioning from a system that does have a QA team to one that doesn't. And I'm thinking, what are the things that the engineering teams are doing differently? And also, what is the future hold for the QA team?
Yeah, good question. I have one right now, right? Because I inherited a team, and I think QA quality is very important to me. It's super important. Like I'm a super advocate of test-driven development. I believe in testing software. I believe in empowering developers to write these tests because they are the ones who can also fix these problems. So what does the transition generally look like, I believe, is the question, for existing QA teams and transitioning them to a world without a QA team. And the way that I generally approach it is the rule is that engineers have to get this to production. They're responsible for getting this feature to production. So now, usually what happens with QA teams is they get a demo by the software developers at probably like the end of a sprint, and then they go and start designing what the test matrix needs to look like, and then they create these tests and then they run them and then they tell the developers, oh, this thing broke. Well, the developers should be doing these things. So if they do them, then the question of what is the QA team's responsibility? The QA team's responsibility is to build tooling. They should be building tooling to enable them to test these things and automate them so that it's not like the developers can't set up this thing and do an end-to-end test and record what they've done. But they need tooling that allows them to be able to automate that in the future so that it becomes a regression test, part of the regression suite. So I think empowering developers is the key. Making sure that they create these things as part of the process. Then the process reminds them, you haven't done this yet. How do you add this into the system?
Hi there, thanks for the presentation. So your section on handoffs covered everything up until deployment, but in fact, every piece of software you build has to be supported afterwards too. What are your thoughts on developers actually doing support post-deployment? Mm-hmm. Is it a good idea? Is it something you do at Instacart?
Yeah, so we basically live in a world where software is in the cloud today, right? And that means bad things will happen. The general idea is that each squad goes on call, right? They are responsible for their software. You can obviously have support teams that help you triage some of this stuff to understand, is it really a P0 type issue that requires, devs to be involved, but, dev teams need to be on call. I think it creates a sense of accountability that, you can't just write bad software, deploy it, and become someone else's problem. It's important that software developers understand the pain of the things that they create.
I get the argument for not having a QA team, but there is a trade-off there. QA tend to be way cheaper. If you're paying a senior dev to do browser testing or accessibility testing, that's a big expense. You can address a lot of that by, like, I just require my developers, they are responsible for unit tests and all that, and my QA is responsible for end-to-end testing. But there still is the sort of black box browser and accessibility testing that's a big expense if you leave that to developers to do. Plus, from a PCI compliance standpoint, I'm a little uncomfortable asking developers to be responsible for testing their code because it's just an extra level of ensuring that what's being delivered is what was asked for.
Yeah, I guess the philosophical answer to that is at some point the developer had tested it. Like at some point the developer will have loaded up in their browser and they would have clicked through these things, right? That was something that they would have done as part of the development. The question is, do you have the tooling to capture what they did, right? So that they didn't have to get someone else to go and verify the fact that it was done. And I think through tooling, you can solve a lot of these types of questions, whether you need to have a team to do it, because the things that like a lot of QA testers do, you can record and you can get them to become automated.